Okay. Good evening, students. Today we are going to study about one of the lessons in physical chemistry, nothing but electrochemistry. Okay. So last class we studied what? What did we study last class? Alcohols, phenols, ethers. Okay. That's also very important lessons. Okay. I studied or not? Studied. Okay. First you study the concept, then after that you go through the MCQ. You also I can able to answer some of the questions without see the book back, the answer. Understood? Then only you have confident about that. Understood? So first of all, study the concept 2 or 3 times. After that, go through the MCQ. This is a way to study. Don't go to the directly MCQ. Okay. So here today I am going to take one lessons in physical chemistry, electrochemistry. Mostly, everyone expecting only the problem. Okay. Mostly problem only asked, but concept also you must know. The concept based sometimes they will ask. Okay. So here we have two part. First about we are going to study about the cells and all. Okay. The Daniel cells, Okay. Then after that we are going to study about electrolyte. Okay. So we have two part will be there. So here first one, cells means what is cell? Cell means it's a device, we can say. It's a device in which the electrochemical process taking place. Wherever the electrochemical process taking place is called cell. Okay. Electrochemical reaction means sometimes electrical energy converted to chemical energy or chemical energy converted to electrical energy. This is called electrochemical reactions. Electrochemical. Understood? Here itself the meaning is there. No. Electrical energy converted to chemical energy or chemical energy converted to electrical energy. That's what it's called electrochemical reactions. Okay. Any device that takes place means we can say cell. They classify into 2 types, galvanic cell and electrolytic cell. Okay. Galvanic cell only we can say that was designed by we can say Daniel cell. Okay. Here in which first what happens means here what's the function of this means here some chemicals are there the chemicals are reacted together to produce what? Chemicals are reacted together to produce chemical energy converted into what? Electrical energy. That's the function of this galvanic cell. Electrolytic cell means what? Okay, when you give electric current, then only the chemical reaction takes place. Decomposition of electrolyte. It is happen only we are passing electric current. No. So when you pass electric current, then only the chemical reaction takes place. So we can say chemical energy converted into electrical energy is called what? In electrolytic cell. Okay. So these are types of cell. Now first of all we are going to study about only the galvanic cell, nothing but Daniel cell. Okay. Okay. Now how they frame the cell means he has taken 2 vessels. One vessel he took zinc sulfate solution. Another vessel he took what? Copper sulfate solution. So mostly same electrode we should dip. Zinc in zinc sulfate, copper in copper sulfate. The 2 electrodes are connected by what? Electrical wire through we have voltmeters in between we have. Okay. The 2 electrodes are connected by electrical wire. The 2 solutions are connected by what? Salt bridge. Okay. Unless if you put salt bridge, no reaction. The reaction, the circuit is not complete. That's the purpose we are using what? Salt bridge. Okay. So whenever the circuit is complete, then only some electrons will be going. Okay. So that's the purpose we are using what? Salt bridge. Then one more purpose is there. That it prevents the 2 solutions to mix up. Okay. So here also some ions are coming. Here also some ions are coming. The one cation anion to form a salt here. After that, this solution will not go. Okay, it will prevent the 2 solutions to mix up. That's the use of this salt bridge. Understood? Then one more very important use is to make the circuit complete. Okay. That's the most important uses of salt bridge. Understood? It's nothing but what? What is this? It is made up of? It's a porous region. Porous region, nothing but it's a filter paper only. You take one long filter paper, you dip in one end dipped in zinc sulfate solution, another end dipped in copper sulfate solution. Okay. So if you do like this, circuit is complete. Okay. So why I am taking zinc in left hand side means zinc is more electropositive, strong reducing agent when compared to copper. Okay. This only having the tendency to deliver electron. Okay. It has the tendency to accept electron. Okay. Who is having more tendency to deliver electron? Then always we keep in left hand side. Okay, if you set the apparatus like this, reaction takes place. Okay, how we know the reaction takes place means here we are getting some deflection in the voltmeter. Some deflection will be there. Whenever electrons are going here, we are getting some deflection. From this one we can identify, so some reaction taking place. Okay, see, listen. Now, if you set the apparatus like this, slowly what happens? Slowly zinc dissolves. Zinc dissolves. Whenever zinc dissolves, what happens? Dissolves from zinc electrode. What happens? It becomes what? Zn2 plus. Okay, plus what? 2 electron. Are you following? Okay, whenever zinc dissolves, these ions, the ions goes into the solution, electrons goes through what? Electrical wire. Are you following? Whenever zinc dissolves, ions goes into the solution, electrons goes through electrical wire. Whenever electron goes through electrical wire, what happens? There is a deflection in the voltmeter. Understood? Now these electrons, here what happens? In left hand side, what happens? Loss of electron takes place, correct or not? Loss of electron. I told you, you just remember LEOGAR. What is LEOGAR? It's our mnemonics. You already studied in lower classes. What is this? What is the meaning for the LEOGAR? LEOGAR means the mnemonics only. Easy to memorize. The oxidation and reduction definition. What? Loss of electron. What? Oxidation, gain of electron, reduction. Are you following? Okay, so loss of electron, oxidation, gain of electron, reduction. Understood? Here, the left hand side, electron is lost, no? So what happens here? What reaction takes place here? Oxidation. Are you following? Okay. Understood? Right. Here electron is lost means we are using the symbol what? Minus. Usually minus means what? Usually we can say in electrolytic cell we usually say cathode. But in this case, totally different one. That's the main difference between this and this. Minus, electron is lost means we put minus. Minus means usually we should say minus means cathode, but here what? We can say anode. That's the main difference. Okay? Right. Next one. What happened? Now the two electrons are going, the two electrons going here. Now who is the inside? Here copper, inside the solution we have copper 2 plus ions, copper 2 plus ion. Okay, these two ions, the copper 2 plus ion receive the 2 electron, receiving the 2 electron. Okay, now it's happening in cathode. So Cu2 plus what? Cu2 plus 2 electron, it becomes what? Copper. Okay, here in cathode, what happens here? Gain of electron takes place. Gain of electron. So we can say what? It's called what? We can say reduction. Understood? It's called, we can say what? Reduction. Okay. So simply is what? Positive. This is called what? The cathode. Okay. This will happen. Okay. So whenever electron here, then are you following? The electron. Okay. In this way electrons are going. Okay. Then only we can say it's called metallic conductions. We have conduction, two types of conduction are there. No. Through electron means metallic conduction. Here. So here electrons are going. We can say what? Metallic conduction takes place. Are you following? Now here zinc becomes what? Zn2 plus ions, no? Okay. Now, this Zn2 plus ions goes through the, porous membrane. It's a porous membrane. Now, ions are going, Zn2 plus ion goes here. Now, C2 plus ion moves towards the electrode and deposit, no? Correct or not? All the C2 plus ion moves towards the, electrode and deposit as copper. C2 plus ion gets to electron, it becomes what? Copper. Understood? Now, okay, now what is the mass? Mass of the electrode? What happened? All the ions are depositing, no? So what happened to the mass? Mass of the copper electrode increases. Are you following? Okay, now here what happened? Here suppose the electrode weight is 10 gram. During the reaction, what happened? All zinc becomes what? Zn2 plus iron. No. What happened to the mass of the electrode? Mass of the zinc electrode decreases. Are you following? It is dissolving, no? Slowly dissolving. Okay. So mass of the zinc electrode decreases, mass of the copper electrode increases. Understood? Right. Okay. Now come to the ions. That the zinc ions goes through the porous region. Then here who is present now? Who is the other ion? Copper ion moves towards the electrode. Who is the other ion? SO4. SO4 2 minus ion. No. Are you following? This SO4 2 minus ion goes through porous region. Okay, these two are coming. These two are coming and make a salt. Then it is called what? Salt bridge. Understood? Zinc ion comes in left hand side. Sulfide ion comes in right hand side. These two are meet together to form a salt. Okay, after that we have fully salt will be there. Understood? Fully salt. Once after that no movement, no. Fully salt is formed means no movement. So if you no movement means after that no current will be formed. So if you want to get the current frequently, understood? We have to replace another filter paper. Understood? Okay, if you want to get the current continuously, so we have to replace the filter paper. Understood? So these are the information about that. Are you following? Okay, so more reactive always keep in left hand side. Then only it delivers electron. Understood? Less reactive mostly in right hand side. It receives electron. Understood? So this is only happening in Daniell cell. Understood? Okay. Now see how to write the cell representation. Then we can add. Can we add? No. What is net equation? Net equation what? Zn plus. When we add, what happened? We can cancel. No. Are you following? Cu plus what? Zn2 plus Cu. Are you following? Okay, this is a net equation. Okay. Then cell representation. What is cell representation? Cell representation means what happened here? Zinc becomes what? Initially we are taking only zinc. Now it becomes what? Zn2 plus iron. No. So zinc becomes Zn2 plus. Double vertical line. It's called what? Double vertical line, nothing but it's called salt bridge. You know. Then copper 2 plus becomes what? Copper 2 plus becomes what? Copper. So understood? Ce2 plus becomes what? Copper. This is called cell representation. Okay. So left hand side we can say it's called what? Anode of cell. Anode of cell. Right hand side is called what? Cathode. Understood? In anode reaction takes place, no. Left hand side what? Anode reaction. At anode only this reaction takes place, no. Then it is called what? Anode of cell. This is called what? Cathode. Are you following? Of cell. Understood? Then how much current is produced or how much voltage is produced? That should be written in right hand side of the cell diagram. Understood? How much voltage is produced? Okay. These two couples are producing some voltage. Okay. I am writing 1.1 voltage. Okay. This is a way to write the cell. If you see this reaction, we can easily understand. Zinc becomes here Zn2 plus. Copper 2 plus becomes copper. How much voltage is produced? This only one line we can understand everything. This is called cell representation or cell diagram we can say. Understood? Okay. Are you following? So this is this is a way to okay. Here left hand side. Then one more thing information. Here electrons are traveling, no? Then it's called metallic conductance. Here who is traveling here in this? Who are all traveling here? Ions are traveling, no? So what? Ionic conduction. Are you following? So both are there. Metallic conduction due to electron, ionic conduction due to what? Ions. Okay. So both are happening here. Understood? Okay. This is a simple way to explain the Daniell cell. Okay. So these two couples, actually this couples producing zinc. Couple means what? Zinc copper couple producing this much voltage. Understood? Right. These couples only, this together only producing that much voltage. But this only producing how much voltage? Only zinc. Only zinc produce how much voltage? By, are you following? Zinc copper couple only producing how much voltage? 1.1 voltage. But I am asking, zinc only producing how much voltage? By 2. By 2, they are saying don't put by 2. Okay. There is a difference in potential produced. Okay. So if you want to find out only zinc potential, then only we use what? Another electrode. Understand? If you want to find out any electrode potential, we are using one standard hydrogen electrode we are using. Standard hydrogen electrode we are using to find out any single electrode potential. Understood? Zinc only if you want to find it means you remove copper and you couple what? She. If you want to find out zinc potential, are you following? Remove zinc and couple what? She. Okay. So any single electrode potential if you want to find it means we are using what? She we can use. Understood? Okay. Are you following up to this? This and all? Okay. See. Then one more information. Suppose if you set the apparatus, what happened? The electrons moves from electrons. In this case, how electron? Case 1. Suppose externally we are giving some external potential. We are giving external potential from outside. See this much. If you set the apparatus, this much only producing this much voltage. But if you apply externally some potential to this shell, okay, what happened? Suppose external potential is greater than 1.1 voltage. Are you following? In the cell itself producing 1.1 voltage. But externally if you produce more voltage from outside, usually electrons is going which, what happened to the electron? Tell me. Usually electrons goes, how electron is going? Zinc to copper, correct or not? Zinc to copper. But if the external potential is more than 1.1 voltage means what? The electron moves from copper to zinc. Are you following? Externally, if you apply more potential means the movement will be opposite. Understood? Usually electron goes in this way. But externally if you apply more potential means what? Electron moves from copper to zinc. Then usually current, I told you, current everyone knows, current all, suppose I told this always what I told, minus no, correct or not? This is current plus no. Usually current travels from positive terminals to negative terminals. Yeah. But we are applying more potential from outside. Everything will be collapsed. The current how it travels? Usually it travels from this to copper to zinc. But if you apply more potential, what happened? Zinc to copper. Are you following? Understood? Okay. Then usually zinc dissolves. Understood? Usually zinc dissolves from what? Usually zinc dissolves from zinc electrode. Correct or not? Okay. Zinc dissolves, copper ion deposit. Usually. Correct or not? Okay. Zinc dissolves from zinc electrode, copper ion deposits at copper electrode. Okay. But if you apply more external potential, what happened? Are you following or not? Usually zinc dissolves. But we can say what? If you apply more potential, zinc deposit. Can we say like this? Copper dissolves. Can you say like this? Understood? Are you following? If you apply more potential, everything will be changed. Understood? If you suppose if external potential is less than 1 point voltage, as usual. If external potential is less than 1 point voltage, electron moves from zinc to copper. Current moves from copper to zinc. Understood? Zinc dissolves from zinc electrode. Copper ion deposited copper. Okay. Copper ion deposited, zinc dissolves. It's normally happen. But if you apply external potential, everything will be changed. Understand? Right. But suppose this is given very clear in your textbook. You just go through. If external potential is equal to, if external potential is equal to 1.1 voltage, what happened? Oh, nothing. If external potential is equal to, it's a very important condition. It's a theoretical part. Okay, just go through. Okay, both are equal means what happened? Nothing happened. Electron will not flow, current will not flow, electron will not move, current will not flow, no chemical changes taking place. Is equal to what? Understood? This one just keep in mind. It's given in a textbook clearly. Okay, understood? Just go through all this. Okay, this is about what? Daniel's cell. Okay, this one just keep in mind. If you already know means leave it. Leogar, just keep in mind. Okay, wherever electron loss is called oxidation, wherever electron gain is called reduction. Understood? Right. Understood? Okay. If you have book means if anything somewhat different from your textbook, okay. Suppose sometimes this is the first time you know about this means just this and all just copy them. Okay. Already you know this and all means just leave it. Okay. Because without this, if I go to problem means it will be a problem. Yeah. Without this, if I go to straight away, you know, we can complete the portion within half an hour. That also we have technique. But without, you must know something about that. What is this? Okay. So sometimes always, always they will not. We can expect problem. Sometimes they will ask theory also. Okay. Okay, it's only simple one. Okay, right. See, I told you why I introduced she. Why I introduced she? She is what? Standard hydrogen electrode. Okay, it is used to find out any unknown potential electrode. Okay, unknown electrode. Okay, potential. If you want to use any unknown electrode potential, this is used. Okay, then its EMF is what? It's very important. Its EMF is what? 0. Standard means you must know its EMF. Standard, we are studying, titration and all we are studying. If you want to find out the one concentration means we are using another solution whose concentration is known. Any solution concentration is known means what? That's called what? Standard solution. Understood? Okay. So by using standard solution only we can find out the unknown solution concentration. That's the way. Like this, by using standard electrode potential only, we can find out the unknown electrode potential. You following? Right. So standard means its EMF we consider 0 because here platinum is a what? Inert electrode. It's a inert electrode. So it will not produce any other EMF. Okay. It is for only act as a platform in which reaction takes place. It is not producing any EMF, but these are all producing some EMF. Zinc, copper and all producing some EMF, but it's not producing any EMF. Then I am saying what? Inert electrode. Understood? Right. Okay. Right. Anything new means just write. Nothing is new means need not write anything. Okay. Simply listening is highly enough. Okay. See here, now okay. Now if you want to find out any unknown electrode potential, see here, to find unknown electrode potential of zinc, what we should do? If you want to find a single electrode potential, what we should connect? We should connect to what? We should couple with She. Understood? So just imagine, it's what is this? Zinc electrode dipped in what? Zinc sulfate solution. We should connect what? What? She. Okay, see, this and all, in between we should connect what? Voltmeter, this and all. Okay. We have salt bridge. Without salt bridge, the circuit is not complete. Then only we put what? Salt bridge. You know that? Okay. Okay. If we set the apparatus like this, what happen? Our aim is to find out what? Zinc electrode potential. Okay. Right. Then, if you set the apparatus, what happened? Zinc is more electropositive, no? So what happened? It's an zinc gives Zn2 plus 2 electron. It takes place at what? Anode. That 2 electrons are received by who is receiving? Who is inside the solution? H plus, no? The platinum electrode dipped in any acid solution, dilute acid solution whose concentration is 1 molarity at 25 degrees Celsius. Understood? This is all to keep in mind. Okay. At cathode, tell me. H plus inside, no? Are you following? H plus inside. That receive, the 2 electron going here, the 2 electron comes here, the H plus ion receiving 2 electron, it becomes what? For balance equation, put 2 here. Understood? Okay, right. Net equation outright. What's net equation? Zinc plus 2H plus gives, cancel, no? Zn2 plus H2. Okay, understood? Okay. What is the cell diagram? All cell representation. What? Zinc becomes what? Zinc becomes Zn2 plus salt bridge. H plus becomes what? H2. Platinum only we put in bracket. Why we put platinum in bracket means it's a, why put what? It's a what? Inert electrode. Inert electrode is not producing any EMF, no. We put in bracket. Understood? Right. Understood? Say, how to measure the electrode potential? See here, this is considered as what? EMF of left hand side. Anode half cell always we should write in left hand side. This is what cathode half cell always write in right hand side. Okay. I told you, what's the EMF produced by She? What's the EMF produced by She? Zero. Do not produce any EMF. So, 0. But here we are getting some EMF. Okay. That EMF is only obtained by what? Zinc. So, write in what? Here minus, I think, okay. I know the value, then I am writing plus only 0.76 voltage. Understood? Right. Now, see, this is called, we have two potential. Electrode potential, cell potential. What is the meaning for this? Electrode potential, okay, and cell potential. What is the meaning for this? Potential between electrode and electrolyte. This is electrode, no? The potential formed between electrode and, what is this? Around this what? Who is present? Electrolyte. Potential formed between electrode and electrolyte is called electrode potential. Okay. Cell potential means potential between two electrode. Potential between two electrode is called what? Or potential difference between two electrode is called what? Cell potential. Understood? That's the main difference between this and this. Okay. Okay. Now, this is the EMF produced by zinc. This will not producing anything. Okay. So, because we can put directly 0. Yeah, some EMF is produced, no. That only we can write. Whatever EMF is produced, that is by only due to what? Zinc. Okay. Because it's not producing anything. Okay. So, what's the then cell potential outright? Cell potential means what? What's the formula? You know that E cell is equal to ER minus EL. ER is what? 0 minus 0.76 minus 0.76 voltage. This is the EMF produced by only zinc. Likewise, you can find it copper also. Copper, if you want to find it, what happened? Instead of zinc, we connect what? Copper. But here, but copper in what? When compared to hydrogen copper, copper is somewhat strong reducing agent when compared to copper. So strong reducing agent only we can keep in what? Left hand side. Understood? Are you following? Okay. Zinc, hydrogen, copper. If you want to find out, if you want to connect these two means who is in left hand side? This is the order. This is the order. This is the order. Keep in mind. This is more strong reducing power than hydrogen. This is strong reducing power than copper. Okay. If you want to connect these two, zinc in left hand side, correct or not? Hydrogen in right hand side. Hydrogen means standard hydrogen. If you want to connect this and this, hydrogen in left hand side, copper in right hand side. This is a way. Okay. This one just keep in. You just register in your note. Okay. Who is having high value, that should be in left hand side. Okay. Understood? This one just keep in mind. Okay. So likewise, we are finding no zinc electrode potential. The same method we have to apply for copper also. Copper, hydrogen in left hand side, copper in right hand side. So if you do this, we are getting, we are getting some potential. So this also, what is this? Outright. Are you following? If I connect like this, suppose if you want to find electrode potential of copper 2 plus ion, copper, what I told you, left hand side C, right hand side copper electrode, just try to understand. Okay. In we have voltmeter, we have salt bridge also, isn't it? Salt bridge also we have. Understood? Right hand, left hand side what? EMF is what? 0. Right hand side, if you connect like this, right hand side we get some value that is obtained only due to copper. Okay. So here we are getting what? Right hand side is what? Plus 0.34 voltage. I know that, only I put. Okay. Outright cell representation. Directly I am writing cell representation. Outright. Left hand side. Who is there? H2 is there, no? H2 becomes H plus, salt bridge, Cu2 plus becomes Cu. Got or not? Okay. Then this is, therefore cell potential is equal to EMF of right hand side minus EMF of left hand side. Right hand side is what? 0.34 minus 0. So answer will be, okay, that's this is EMF produced. Okay, understood? Right. Understood? This is all okay. This simple sum, this keep in mind. They'll give the value, okay. Any doubt here? Okay. This formula only just keep in mind, okay. Okay, right. Sometimes I'm saying this is left hand side, this is right hand side. Okay, you are simply okay sir, right hand side and left hand side, this answer. Okay, sometimes they won't give anything, left hand side, right hand side. You must know how to find out. Suppose for example, 0.2 plus by simple, it's already given value. Copper 2 plus by copper becomes, okay. Find out cell potential. How to find out? What is the formula? ER minus EL. How we know? This is, which one is ER, which one is EL? Now we are studying Daniel cell. Then only we know. Zinc always left hand side. Yeah. This the copper always right hand side. Then only we know. Okay. So I am giving one clue. Suppose not given anything means, see, left hand side always strong reducing agent, less value. Just keep in mind. Less value means among this who is less value? It's a less value. Left hand side. Okay. Just keep in mind. Left hand side. Okay. less electrode potential. Right hand side, more electrode potential. Let's keep in mind. Okay. So if you know this means you can suppose both are positive means this one is negative, one is positive. So simply is called negative, is called positive. Both are positive means less value. Among the positive, who is less value? That is left hand side. Okay. Right. Now what's the point of 0.34 minus, understood? 0.34 minus, already minus, no? Cut or not? 0.34 plus, no? Cut or not? 1.18. I told you in the beginning, Daniel cell. What's the answer? Yeah, I put only 1.1 voltage, no? This is a way to get. Understood? Right. Okay. So this is a very important, one important clue. Okay. I found out this clue for go through many sums. Okay. Then only I can able to give this. This is a way to do. If you follow this, you can able to solve some sums. Okay. Right. Beginning also I don't know why they put we always minus, no, 0.34 minus this one. Why we should do in reverse direction? Okay. So this is a clue. Just keep in mind. The less negative means it's a strong reducing agent. That's the meaning. Strong reducing agent only will always keep left hand side. Okay. Okay. Right. That's all. This one. Okay. Next one. I written all this. This one. Right. Okay, next one. Just write. The form under this, right? Relation between Gibbs free energy change, and standard electrode, standard Gibbs free energy change and standard electrode potential. What's the formula? Gibbs free energy means what? Not means standard is equal to minus NF. Simple formula. Keep in mind. This is the relation between standard Gibbs free energy change and standard electrode potential. Okay. Conditions means if you want to suppose if del G naught is negative, that reaction is called what? Spontaneous reaction. Okay, just keep in mind. Positive is called, understood? At the same time, E naught is positive only spontaneous. Okay, spontaneous process. Understood? E naught is negative is called non-spontaneous. It's quite opposite. Okay. The process takes place what is spontaneous? What is spontaneous? I am teaching the lesson continuously without seeing book. That's called what? Spontaneous naturally. Okay, naturally happen, no? The reaction happens naturally, it's called what? Spontaneous. Okay. Okay. All the toppers are spontaneous students. Okay, all the first rank holders are spontaneous. They will study own. Okay, without any stimulation, they will study own, no? If it takes place naturally, it's called what? Spontaneous process. If it does not take place naturally, it's called what? Non-spontaneous process. Understood? Right. Okay. So this condition just keep in mind. Right. So based on, I'll give one some simple one. Just write down, note down. Suppose Zn plus Ce2 plus gives Zn2 plus Cu. Okay, what is the n value? E naught value I'll give. E naught value is what? 2 voltage. Delta G question mark. Write fast. What's the formula? This only just copy them. Okay, formula, this one, that's all. Write something. Then we can write. Delta, what's the formula? Delta is equal to minus NF E naught. What is N value? N value is what? Zn becomes what? Zn2 plus. So how many electron? 2. So 2. So minus 2 into F is what? F is nothing but Faraday, no? 96,500 Coulomb. Okay, this is memory, keep in mind. 1 Faraday is equal to 96,500 Coulomb. Simple sum. 96,500 into what? E naught is what? It's given, no? 2 voltage, that's all. Answer will be in joule per mole. Okay, just minus, no? Then only it's called what? Spontaneous process. Do, write fast. Just note down. Sums and all, just note down correctly. Formula, sums. Very simple sums only I am giving. Based upon, by using this, you have to see the other sums in your, guide and all. You put like this, question, or put problem, just under this you write. Then you put some important symbol. The negative terminals. Negative terminals is what? Anode is negative terminals. Yeah. So you must know the reactivity series. You must know. Suppose I told zinc, hydrogen, then copper. If you connect this and this, who is negative terminal? Zinc. Yeah. I told this is the order, no? If you connect this and this, who is negative terminal? She is the negative terminal, like that. That reactivity series, just keep in mind. That reactivity series, that potassium, sodium, aluminum, zinc, iron, lead, hydrogen, copper, silver, gold. At least you must know this. Keep in mind. It's there in your textbook clearly. Okay, this order, if you know, means it's more reactive. More reactive means what? Strong reducing agent. This is a strong reducing agent. The strong reducing agent, it's called, I told you, strong reducing agent. This is strong oxidizing agent, but weak reducing agent. Understood? This is all, just keep in mind always. Okay. Nida, I written this problem. Okay. Next. Okay. Please keep in mind. Okay, you know that it's given in textbook clearly. Okay. Then one more formula, right? Relation between, relation between um, equilibrium constant and standard electrode potential. Standard electrode potential. Okay. Write the formula. Log K is equal to Ne0 by 0.059. What is K? K is called what? Equilibrium constant. Okay. Write one question. That is E0, 0.059. Okay. Zinc plus C2 plus gives what? C2 Cu plus Zn2 plus. What is N value? N value here what? 2. Following. N is always 2. So what is K? Log K is equal to 2. Kata. But they are asking K. Are you following? Simple. Simple sum only. Okay. For crash courses, everything short. Suppose if you have, one year course means, okay, we have to put one big sums. But anyhow, this is also one sum. It's not a small. But you must know the concept. What's happening here? Then only I selected some easy sum. If I took one big sum means it will take some time, isn't it? You know that 1, 2, no? 2 here, what? 0.059 by, 0.059, cancel, no? Is equal to 2, no? Log 2, but they are asking only K. What is K, no? K is equal to, when it goes here, it will be 10 power something. Just keep in mind. Actually, log to the base what? 1. Log to the base, 10 is there. Original 10 is there. Okay. So K is equal to what? 10 power 2. That's the answer. Understood? Just note down. Note down first. K is equal to 10 power 2. That's okay. Are you following? Simple sum. Sometimes one sum is there. I think 30 is coming here. So 10 power 30. Everything cancel. Answer 30. Okay. Understood, right? Next. But I didn't do Nernst equation, no, still. Now what is Nernst equation? Write the form. E is equal to E0. First part of the sum we have 4 formulas. Okay, 1, 2, okay, 3 formulas we did. This is the 4th formula. 0.059 by N log K, no, it's a formula. Understood? So mostly they'll give, E naught they'll give, n, we know, we are doing, any sum we can get, the n value, okay. Suppose for example, CR becomes CR3 plus, FE2 plus becomes FE3 plus, FE3 plus becomes FE2 plus. Okay, what's the, okay. Fe, Fe2 plus becomes Fe. What is n value? 3. Why how you can say 3? What is n value? Not 3. The formula and everything, this is given, n also we can get it from here. Concentration means product by reactant, this is all okay. Okay, how to find out n value, here, see, Cr becomes what? Cr3 plus how many electron? 3 electron. Listen, look at the board. Fe2 plus becomes what? Fe, no? Fe, yeah? Okay, right. Plus what? 2 electron. Correct or not? When you add, what happens? It should be same, no? It should be same, no? Okay. So, electron should be same. Then this equation multiplied by 2, this equation multiplied by 3. Now, then only it will be same. What it comes here when you multiply? N is equal to 6. Understood? Okay. They will check whether you know the concept or not, that's all. Okay. So this also just go through. Always simple question they won't ask. This also, if you have different, no, this is for 2 plus, this is 3 plus means mostly n will be 6. Okay, understood? Right. So if this is everything they will give, you can substitute, you can get the answer. Okay. You practice on sums based on Nernst equation. Okay. Right. Just note on this one. How n is equal to 6 comes. Okay. 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 One small break for 5 minutes. Okay. After that, I'll start. Okay.